Imagine your ship loses control above a star only the size of a city. The surface below looks smooth, almost peaceful. Then the gravity takes hold. Before your brain can understand what it is seeing, your body is pulled downward at a terrifying fraction of the speed of light. One sugar cube of this star would weigh 1 billion tons on Earth. And somehow, this is not even number one. Today, you are visiting 7 real places in the universe where no human could survive. For each one, there are only 3 questions. Where are you? What kills you? And how much time do you have? Number 7. Venus. You wake inside a damaged lander. Outside the window, the sky is yellow, the rocks are orange, and everything looks strangely still. For 1 second, Venus almost resembles a desert on Earth. Then the temperature warning appears. The surface is about 467 degrees Celsius, hot enough to melt lead. The atmosphere presses down with roughly 93 times the pressure at sea level on Earth. That is similar to being almost a kilometer underwater, except the ocean is made mostly of superheated carbon dioxide. Step outside without protection, and there is no dramatic explosion. Something worse happens. Your lungs cannot work against the pressure. The heat pours into your body from every direction. Your suit seals soften. Electronics fail. You are not simply burned. You are slowly cooked inside a planetary pressure chamber. The strongest landers sent to Venus lasted only about 2 hours. You would last minutes at best. But Venus at least gives you ground to stand on. Number 6 never lets you land. Number 6. Jupiter's deep atmosphere. Imagine falling through clouds large enough to swallow Earth. There is no surface below you, only thicker gas, higher pressure, and darkness. In 1995, NASA's Galileo probe entered Jupiter's atmosphere at about 106,000 miles per hour. Its heat shield faced temperatures near 16,000 degrees Celsius. The probe experienced more than 200 times Earth's gravity during entry, survived, opened a parachute, and transmitted for 58 minutes. Then the pressure won. Your journey would be shorter. The entry shock would probably kill you first. If some impossible capsule protected you, you would sink past violent winds into warmer and denser layers. Gas would become a strange, compressed fluid around you. The pressure would crush the capsule, and the remains would keep falling until the heat vaporized them. Jupiter does not have a floor. It has an execution that becomes more complete the deeper you go. Now remove the atmosphere. Put almost the mass of a sun beneath your boots and try to stand. Number 5. A white dwarf. A white dwarf is the exposed core left behind after a star like our Sun dies. It can be roughly the size of Earth, while containing a large fraction of a star's mass. From a distance, it looks like a small white sphere. Up close, it is a gravity trap. The moment your boots touch the surface, your body no longer behaves like a body. Your legs cannot support your weight. Your bones fail. Your chest collapses against the ground. Even falling from a tiny height would release devastating energy because the star pulls so violently. And the surface may still be tens of thousands of degrees. You are crushed and burned almost together. There is no time to scream, no heroic final message. Just a thin layer of matter added to a dead star. But at least a white dwarf has a visible surface. Number 4 hides its deadliest part behind light. Number 4. An active black hole. You have seen the image, a black circle surrounded by a glowing ring. The obvious danger seems to be the event horizon, the boundary beyond which nothing can return. That is not what kills you first. If the black hole is feeding, gas and dust spiral around it in an accretion disk. Friction and gravity heat this material to millions of degrees. Above the disk, a corona of particles produces intense X-rays. Near the poles, jets can launch matter at almost the speed of light. Your ship would begin absorbing lethal radiation long before reaching the horizon. Its outer skin would heat, sensors would turn white, electronics would fail. Then, the atmosphere inside your cabin would become the last hot thing you ever breathed. Here is the disturbing twist. A quiet, supermassive black hole might allow you to cross its horizon before tidal forces tear you apart. But a bright, active black hole may kill you while you are still far enough away to see it. The darkness is not the warning. The light is. And now we reach a place that can destroy you without heat, pressure, or even physical contact. Number 3. A Magnetar. A magnetar is a neutron star with the strongest known magnetic field in the universe. Its field can be about 1 trillion times stronger than Earth's magnetosphere. Imagine approaching one inside a metal spacecraft. Every tool becomes a projectile. Electrical systems fail. Charged particles in your body are forced to respond to a magnetic field no living organism evolved to survive. NASA has described the field within roughly 600 miles of a magnetar as powerful enough to disrupt matter inside a human body. You would not need to touch the star. You would not even need to see the surface clearly. Then there are the bursts. A magnetar can release sudden floods of X-rays and gamma rays without warning. One moment, your instruments show a tiny point of light. The next, radiation crosses your ship and turns living tissue into damaged chemistry. So pause for a second. If a star can kill you from hundreds of miles away, what could possibly be worse? Getting closer. Number 2. A neutron star. This is the object from the beginning, a dead stellar core, city-sized, with up to about twice the mass of our Sun crushed inside it. You do not land on a neutron star, you impact it. As you fall, the difference in gravity between your feet and your head stretches your body. The surface rushes toward you at a significant fraction of the speed of light. When you hit, the energy of your motion becomes heat and radiation. Your atoms spread across the crust in a film far thinner than anything you could see. The star barely notices. And remember the sugar cube. On Earth, that amount of neutron star material would weigh about 1 billion tons. The matter beneath you is so dense that ordinary ideas like rock, floor, and landing stop making sense. For you, survival time is effectively 0. But number 1 is not a world you land on. It is a weapon that can reach across a galaxy. Number 1. A quasar jet. At the center of a distant galaxy, a supermassive black hole is feeding. Around it, a disk of gas glows at millions of degrees. The engine may be only about the size of a solar system, yet it can produce hundreds of times more light than an entire galaxy filled with 100 billion stars. Then, the magnetic fields above the disk focus part of that energy into 2 narrow jets. Some extend for hundreds of thousands of light years. The particles inside move close to the speed of light. Now imagine your planet lies directly in the path of one. You do not see a wall approaching. The first warning may be the sky becoming impossibly bright. High-energy radiation strikes the upper atmosphere. Satellites die. Chemistry changes. The protective ozone layer is attacked. At close enough range, the side of the planet facing the jet is sterilized before anyone can understand what is happening. That is why the quasar takes number 1. A neutron star destroys you when you reach it. A quasar can destroy you from a distance so vast that the source looks like a single point in the sky. 7 places. 7 different executions. Heat on Venus. Endless pressure inside Jupiter. Gravity on a white dwarf. Radiation around a black hole. Magnetism near a magnetar. Density on a neutron star. And finally, a beam powerful enough to turn part of a galaxy into a kill zone. The universe is beautiful because we observe it from the one place built to keep us alive. So, which location should be number 1? And if you think the black hole deserved it, tell me why in the comments. Subscribe, because the next video on screen takes you past the glowing disk and asks the question this list avoided. What would you actually see after crossing the event horizon?